let's take a look at where we're headed. If I could have your eyes up here. As we always do, we kind of take a look at where we're going today. So we want to take a look at what our lesson's going to be about today and what I hope to accomplish and help you learn to do, all right? So I can use a solution set of 1 to 10 and prove the values of variables with substitution. Let's look at the first part of that, because that's our I can statement. I can use a solution set of 1 to 10. Does somebody have an idea of what that means? Can somebody tell me what we mean by a solution?
An answer.
An answer. So we know that our answers on our activity today, what are the possibilities for those answers? Yeah, Gavin?
1 to 10.
1 to 10. So if you're working through this activity and you get 14, could you be right?
No.
If you got 4, could you be right?
Yes.
Okay, so we want to make sure that as we're solving our problems today, that we fit into that solution set, all right? And prove the value of variables with substitution. I want you to think in a minute, we're going to talk about what those words mean. Some of them you know, some of them you don't. By the end of today, hopefully you'll know both. All right, so let's take a look. Once we have done some practice problem together and talked through our vocabulary, then you're going to do some group work. As always with group work, please use your polite prompts. No, not, what are you saying? Or what will get it? We've got some good prompts that we can really help each other think, and we can also explain our thinking to someone else. All right, so use our prompts. And we are going to focus in today on how we got to solution. What strategy did we use? There's not a magic list of strategies, but you guys will come up with good ways that helped you get to solution. All right? And then our homework is called Balance Puzzles 2. We may or may not get to that during this class period. We'll just see how the class goes. And if we don't have time to kind of talk about that, then we can talk about that in enrichment today. All right? Are we good? All right. What I'd like to do is to take a look at a portion of what we have here. And would you please take a look at your note taker for today? We opted to keep the note taker out of our journal so that we could use it today, and it will eventually be glued into your interactive notebook. But what do you notice is across the top of your note taker? What do you notice there? Sid?
It says I can prove equalities using substitution when my solution set is 1 to 10.
All right, so once again, we know our focus, so we know we gotta find 1 to 10 as far as our answer. All right. Now let's take a look at a few vocabulary. A couple of them we're going to do right now, and then the others we'll look at as we go through. Can somebody tell me what an equation is? What's an equation, Jaysha?
Like 2 plus 3 equals 5.
Awesome. Let's take Jaysha's example. 2 plus 3 equals 5. What do we know? What made that an equation?
The equal sign?
The equal sign. And what does that tell us? What does that tell us? Sid?
There's like a problem in there and you have to find a solution.
You do. Well, what do we know about the solution of 2 plus 3? What do we know about the solution of 5? Donovan?
It equals 5.
They both equal 5. All right. So an equation has an equal sign. Let's make sure I got my pen on. There we go. We've got an equal sign. And it separates 2, and I'm going to leave a blank here because somebody's going to come up with that word for me. An expression is merely numbers or numbers and letters. But I want you to think, we know 2 plus 3 says the same thing as 5. What do we call it when each side of the equal sign is the same value? It's another word we've used. Often we used it with fractions. It begins with an E. Jacqueline?
Equivalent?
Equivalent. So we know we've got two equivalent expressions, and we recognize right away that's true because of the equal sign. All right? All right, how about a variable? Who can tell me what a variable is? Maddie?
It's something that substitutes a number that you don't know, like this plus x equals that.
All right. Something substitutes a number that you don't know. Awesome. All right. I didn't even need to tell you to jot them down. Awesome. All right, because this vocabulary, we need to know what it is as we solve our problems. And I want you using that language. I think the variable such and so, or in this equation, I think the variable means this. All right, because we want to practice those words so that we know how to use them. All right, before we deal with the other two terms, let's look at our first example. Triangle plus square is star. As we go through our practice example here, if you look over on the right-hand side of your first box, it would be your second box down on the left. You all see where that is? And if you look at it, it says practice example. In parentheses, it says number shapes. Do we all see where we are?
Yeah.
Put your finger on it. And once I check one person in each group, Thomas, check your group. Who's got it figured out? Sid, check your group. Donovan, check your group. Aiden, check your group. Susie, check your group. Jacqueline, check your group. Make sure everybody's in the right place. Awesome. Okay. All right, we're good? Okay, cool. Now, on the left-hand side, we have the symbols we are using. But on the right-hand side, what words are written there in that box? Lauren?
Equations and substitutions.
Equations and substitutions. This is our first equation. We will have a total on each example of 4 equations. So don't write them too large. All right. Okay, so the first thing I want you to write down in that equation substitution area there is go. Triangle plus square equals star. And it don't spend forever. It doesn't have to be a perfect look. But it goes underneath there. And remember to leave enough space that you can write 3 more equations and show solution. All right? Do we all see where we are next right there? Okay, cool. Awesome. Now, I want you to talk in your group. We have 3 variables here. I want you to tell me what the value of each variable is. Talk in your group.
How would we figure out the value?
Well, it's 1 through 10, so it could over here.
Alyssa, what? We move this over here, please. Thank you.
Yeah.
What?
They both can't be bigger because it has to be 1 through 10.
How do you know?
So it's
You would have to know what the star is, though, to be able to figure out those.
Or you have to know the triangle. Well, yeah, you would have to know the stars, but it's just pretty much like 2 different numbers
Yes,
close to each other.
Eyes up
Another
front
number
on
in
3,
between 10.
2, 1. Awesome. All right. Do I have somebody in this group who wants to report back?
Solution.
Can't figure out a solution. All right, I'm okay with that. Did anybody else find that issue? Okay, so what is our issue? Why can we not find a solution? Kevin,
You can't have a problem that's all variables.
why not?
Well, then we wouldn't have anything to base it on. We need other problems to tell us what at least 1 or 2 of those variables are.
All right. So we've got to limit the possibilities. All right? Right now, we have a limitless well, not limitless. What are our limits on the variables? Luke?
1 through 10.
1 through 10. And what is true about a triangle, a square, and a star? What do we know about those 3 things? They're all shapes. And what is going to happen when we use them in this problem? Anybody know? This may be a concept with variables you may not know yet. Maddie?
They're gonna turn into numbers once you figure out the numbers.
They're going to turn into numbers. And what about those numbers, Sid?
Well, we talked about that, like the sides, the amount of sides might be like what the number is. Like a
Okay.
triangle would be 3.
It could, and that might be a kind of a trick in this problem, and we'll see if that works later. All right? Well, what do we know about all of our triangles, all of our stars, all of our squares?
They're 1 through 10, and the first 2 can't be both 5 or bigger.
Okay, all right. Why? All right, so we know that. Can the triangle be the same value as the square?
No.
We cannot. And if you didn't know that about variables, why? Why can the triangle not be the same value as the square? Elisa?
Because then they'd be the same shape.
They would be the same shape. So we know if we have different symbols, we have different values. We good? All right. So right now we have not a limitless, but we certainly have a fairly good choice of possibilities. So let's look at our next equation. Now, before, and I know your minds are already going there, before you come to solution, one of the things that I want to introduce to you today is that what we are looking at today is called a system of equations. And actually, we usually deal with systems of equations in algebra, like in 7th and 8th and high school. But all it merely means is, do you see this triangle here? Yeah. It has the same value as this triangle. Often when we change variable problems, we know the word variable means varies. But in this set of 4 equations, wherever you find a triangle, it's going to have the same value. Wherever you find a square, you have the same value, and wherever you have a star, same value. Okay? All right. Now, can we find solution? Talk in your group about what this helps you determine. Go ahead.
3 plus stands for 3.
Yeah, because if it's 4 goes to 12.
And if it's 1, then it'd be 2.
Yeah, sure.
It could also be 1.
No, it can't.
Because then triangle.
Yeah, so square would have to be worth 2 triangles.
Yeah.
Understand that.
Okay, so
Oh,
we only have 1 triangle, so this would have to be, the square would have to be worth 2 triangles.
yeah, but
And that's all we know so far.
So then the square would be 6.
Up front on 3,
Still what, really?
2, 1. So what did we learn? What did this problem help us to do? Peter?
The square is 2 triangles. Because 3 triangles equals the star.
Awesome. Awesome. Oh, I think I'm gonna get out my midnight box now. Peter, a bright shiny moment for you here. There you go. All right. Can somebody explain what Peter was saying there? That's a cool concept. What was he able to discern there? Chris?
That if 3 triangles equals a star, and then the square would be 2.
All right. So we now know that this is worth 2 triangles. That will help us, won't it? Is there something else that we know? Kylie?
The triangle has to be like 1 through 3,
And can you tell me why?
because the very least you could get before reaching 10 is 3 times 3 for the triangle. To get
All right.
the star.
If these triangles won, then what would our star be? Maddie?
Well, I was gonna say that that one triangle is 1/3 of the star.
Awesome. Oh my gosh, I'm gonna run out of these things. All right, so what do we know about our star value? What's our star value gonna be? What do you think?
Well, if the triangle is equal to 1, the star value would be 3.
Okay, all right. So we know the star is potentially 3. Do we know any other value for the star? Sid?
Well, it has to be more than 3.
And why is that?
Because if like Max said, if the triangles are 1, then that'd be 3. You can't have less than 3.
Okay, all right. So what other values could it be? Aiden?
Well, the star could be 3, 6, or 9.
3, 6, or 9. All right. Lauren?
But how could it be 9 if you would do the 3 times 3, but you said they can't have the same value because they're different shapes?
And in here? Right here? Excellent question. Can somebody answer that for Lauren? If there's a 3 here, how can the triangle also be 3? Luke?
Because since that's not an actual variable, it's okay.
Okay, because this isn't just a number. Now, if it were x times triangle, then x and triangle could not both be 3. But since we've just imposed this 3, and we're ready for our next vocabulary term, does anybody know what this number is called?
Coefficient.
Donovan?
A coefficient?
A coefficient. So what is a coefficient? How is it being used here, Susie?
I think it might be the thing that you do know.
It is something you know. And what kind of math is happening here between the 3 and the triangle? What kind of math is that, Thomas? Multiplication. So a coefficient is a number. What? What's happening?
A number that tells you how many of each variable there
Okay.
are.
Number, and I'm just going to shorten it because I'm out of space, but that's a great response. Number of each variable. And we know we can just multiply it or we can add it repeatedly to get to our solution. All right? Are we good? Let's take a look at our third equation. Does this help us find solution? Thomas?
The triangle would be 3 because the star would then be 9, and then the square is worth 2 triangles, so it would be 9 minus 6 equals 3.
Okay, it could be 9 minus 6 equals 3. Could it be something else?
Yeah,
Jasha?
Well, looking at it, since you have one of the possibilities for the star being 9, and you look at it with the 3 on the side, the triangle could always be 1 because you see there's 2 triangles under the square, which might make the square 2.
Okay, so it could be 1, 2, 3. Another valid solution, right? Okay. Chris?
It could be 9 minus 8 equals 1.
It could be 9 minus 8 equals 1. We still don't know a whole lot, but we're kind of assuming we know 9 and 1 might be a possibility because we see those as choices. But 9 is the value if we have what for the triangle?
3.
Hannah? 3. So if we have 9, we'd have to have that 3 with it, but we frankly don't know. So let's take it to our fourth session, or our fourth statement. When you receive your set of cards, you will notice that one of the cards has a dark dot. 3 of the cards have just white clear dots, but one of the cards has a dark dot. The dark dot is used only if you can't figure out solution with the first 3. And we couldn't find solution with the first 3, so now we have the fourth one. Star minus 2 is square. Star minus 2 is square. Anybody have an idea on solution? Elisa?
The star equals 6.
And how did you get to that, Alicia?
Because
For the other clue, it's star minus square equals triangle, and so if you do it the back way, then triangle equals 2, and then star minus triangle equals square. So,
All right. Wait, and so what did you use? What was the strategy you used there, Elisa? Elisa, sorry. What did you use? You just said did you use this equation or this one?
down.
Okay, so if we look back at our other equations, we can utilize other equations and their relationships, and that might go under your strategy part, okay? Now, so Elisa is proposing that the star is worth 6, and the square is worth 4. All right, now, you don't need to do this on your paper, but I'm going to go back. She says the square is 4, so I'm going to put 4 where the square is. She said the star is 6. And what would our triangle be once we have put those values in there? Kevin? 2. Does this make an equality? Does this make an equality?
Yes.
Does this make an equality? And we know that one does, because all the values are there. All right, so we have proved this. Now, when we get going on our lab here in a couple minutes, when you raise your hand to say you've got solution, you won't have to say, am I right? Why won't you have to say that? Maddie?
Because if you have it right, all the values will fill in.
Oh, and what do we call that when we fill in values like that? What do we call it? Patrick? Substitution. So, what we do with substitution is we fill in values, and this becomes our proof that we are right. So I don't expect any of you to go timidly, Mrs. Gonyou, am I right here? What I expect you to say, Mrs. Gonyou, our group is correct on this. Because if you will notice, we substituted 2 and 4 and got 6. We substituted 2 and that is equal to 6 when we multiplied by 3. 6 minus 4 is 2 and 6 minus 2 is 4. It checks in our system. We know we are right. Thank you very much. All right? So it's kind of one of those things that when I come over to check you, it's not going to be, are they right or not? Of course you're right, if you've done the procedure. So let's talk about the procedure and we'll start our lab. So you're going to get 4 equations. Now, 3 of them you can look at. Which one can you not look at when you start, Lauren?
Go with the black dot.
The one with black dot, because you're going to challenge yourself to see if you can figure out a solution without that one. But if you've worked for 4 or 5 minutes and you guys are like, I've tried this, it just doesn't work. Then you can turn over that card, all right? And I'll let you know which one that is as I hand them out, all right? But I'm also going to give you something else you can use to help solve. Each of you will get an envelope. In that envelope are equal signs, any numbers you need, and stars, triangles, and squares. Because when I hand out the cards, if I hand out a card to Thomas, Thomas keeps that card. He's in charge of that card. He shares the information from that card. All right? But what he can do is he can help get his card set up so all can see it. Alyssa will have a card. And she's in charge of that card. And in charge of that information and making sure the group is thinking about that. If somebody says, I think the star is a 4. She says, that won't work in the equation I have. Because if you put a 4 here, it won't work with this. Kevin will have a card. Same thing. He's going to be the pro on saying, that sounds good for my card. Oh, that's not going to work. Hannah has the card with the black dot. And she's going to keep it face down unless you need it. And Luke is going to be the manipulator. That means when Thomas shares his equation, he'll set it up. And then when you get to level 2, that's just level 1, then whoever is doing each role, it rotates. So everybody gets a chance, pretty much, to do each different role. Yeah, Peter? Huh? And what will happen with you, Peter, is because you're my only group with 4 people, if, let's say, Patrick has the black dot card, then he leaves his face down and the other 3 of you read your card in turn and set it up, just like everybody else does, but you'll set up your own. Okay? All right? We good? All right. So, I'm going to come around. I'm going to ask one person from each group to come up here and get the number shape. And I want the person who's sitting in this position. All right? So the person sitting in this position is going to get the number shape. And I'm going to come around with the first set for each group because I want to make sure we're not peeking with the card. All right, let me find the card. Kyle, you have that one. Don't turn it over. Max, hand those out to the rest of your group. Maddie, you have the one that isn't turned over yet. Let's get to work, guys. Hand that out to the rest of your group.
Jackie's first with that.
Once you have materials, you may begin. All to make sure everybody has one of those and one of you can be the manipulator. Okay? Okay. All right. See here. Okay. Do not turn that over unless you need it. Thomas, make sure everybody has one and one person.
I have the easy job of sitting down.
All right. Sit, don't turn that one over yet. The rest of you, Patrick, hand those out.
You get the black dot one. What do I sit here?
I guess you just got. Don't turn it over until you need it. Make sure everybody gets one of those. Guys, you all have materials. Please begin.
Okay. I'll hurt myself. Okay. Triangle plus square equals 6.
Mine is triangle plus star equals 3.
Oh, yours is star plus star. What?
And I have star plus star equals triangle.
I have triangle plus star equals 3.
Well then we obviously know that triangle is
All
a
right,
big number.
now, Sid has the one face down. You guys, because you're a small group, thanks for getting those all sorted out, Sid. Each of you needs to set out your problems so each other can see it, okay? Guys, do you have your
Setting out my problems.
set out? Okay.
Set out.
Are you setting them out, Kevin? Are you the person? Okay. Awesome.
So we know we have the answer.
Yes, one of them would have to be 1 and one of them would have to be 2.
Kayla, you got the tough job, right? Okay, and are you guys getting them written down? Awesome, Kyle, you're already there. Okay. Guys, are you getting the problem set up so that you can use the manipulator?
Where do we have to write them? How do we write them down?
Excellent question. Okay, and this is what we want. Whose is this card? Okay, then it shouldn't be there. You each have who has the black dot?
I do.
Okay, all right, so here's what we need to do. Lisa has star plus star equals triangle, all right? So, who's doing the manipulatives? Is that you, Amika, this time?
Yeah.
All right, surprise, I bet you didn't know. All right, so what Amika is going to do is she's going to create this, and all of you will write it down here.
Oh, okay.
Okay? And then Susie will do hers and Jasha will do hers. And then you'll all be able to see them at the same time. But what I don't want is like Jasha and Elisa over here looking, trying to figure it out, and not including you guys. So by one person setting them up so you all see, everybody gets to do the thinking. All right? And only, Maddie, turn that over if you need it. And maybe once you think you got solution and you plug it in, you turn it over and say, we are victorious. All right?
Okay. I already got it.
You guys, you get it set up. Okay, I see one set up here. And that is, does somebody have a second one that they can?
Yeah, we're trying to.
Awesome. And then if you would get that set up also, and you can leave it right there. We've got plenty of manipulatives. Okay? All right.
So then, mine is triangle plus star. Three.
Now, eyes up here for just a minute. I have two groups who have hands up who think they have solutions. Now, they may be good, three groups, and they may not be. But here's what I expect. Number one, they have all can show me that they've substituted the values in. Number two, they've listed at least one strategy of how they got solution. If they used more than one, they can list more than one. If you have solution and you've done the substitution, and that is true with all group members, then I will come around and check.
The strategy.
Because we automatically knew that 2 plus 1 equals 3. There's no other answer. There's no other way you can solve that.
Equal to 1. And then triangle would equal 2, which would prove that triangle plus star would be 1 and then they get 3.
Everybody has.
And also triangle, then if we
And
get
does
6,
everybody
then
have a strategy listed? What strategy did you guys use this time? Okay, and what did you do though with that?
For one of them, it was triangle plus star equals 3, and we knew automatically that 2 plus 1 equals 3. And so with the other equations, we try to plug in 2 and 1.
All right, so can I say guess and check? Is that kind of what you used? All right, and do you have it listed next to the equation so I can check it?
Yeah.
Awesome. All right, collect that, and I will give you level 2. Who gets the black dot this time?
Well, I had it. And then
Okay, let's get our.
We don't have any plus signs, so just put them next to each other.
And you have all 4 there, Thomas?
And if you need to put any stuff over
Okay, then Kevin gets the black dot. You guys share these around, and let's go to awesome.
square plus triangle.
And then what's Thomas's?
Square plus triangle equals star, right?
Here, so I can just see it.
Okay.
But did we able to get it sub?
Yes.
Okay.
we didn't use the
Certain
4.
you're right?
Yes, because they all counterbalance.
All right.
Okay, so first when we start at the bottom, it's triangle plus star equals 3. The only triangle is 2 plus 1. So anytime that says star plus star plus star equals 2, one star from the third problem, you put it up there. 1 plus 1 is 2, and choose the problem right there. So you have to find out like 2 plus what would equal 6.
Wait, why did we
Awesome. Awesome. Excellent.
Good job.
Thanks for volunteering your explanation. All right. Those go back in there. Who gets the black dot this time?
I'll take it.
Okay. Gavin, leave it down. Who's doing manipulatives this time?
I think I am.
Okay. And we just kind of rotate them. Share those around. We have all 4. Awesome.
That's a square. Those are equal signs.
Why are you loving this? Okay, so we have star plus star equals triangle. So if triangle plus star equals 3, then
Okay.
triangle equals 2 and star equals 1. And then if triangle plus square equals 6, then that means, and if triangle is 2, then 2 plus what equals 6. So.
Awesome. Awesome. You guys are great. So here's what I need. This one said number shape 1, and this one says 2, and you just did it up here.
Oops.
And that's okay. So just make this one 2, Raven. Okay, I'm okay with that. It's not a big deal. All right, and you did the same thing. So just make this one 2. You're good. You guys are good. So who gets the black dot this time?
Not me. Raven.
Okay, so Raven gets the black dot. And who gets, and then you share the manipulatives. Do we have all 4 here? Awesome. Oh,
Here, Peter, give me your stuff.
Nice stuff.
Okay, that's not a word. Whatever.
Give me your stuff.
So we said that we eliminated numbers one by one to figure out the variables, and like we used different, like we just looked at different ones and saw if they would work in all the problems, and then started figuring it out.
okay,
such
so
as-
kind of a guess and test? Yeah.
Like such as this has to be under 5 or under because it can't go over 10.
Okay.
But then we realized triangle plus star equals 3, so star had to be under 2, 3 or under. And then if you and then it would be and then you would realize that star would equal 1 because 2 plus 1 would equal 3.
Awesome.
And then triangle would equal 2, and then 2 plus square equals 6, so this would be 4.
Awesome. Great strategies for both of you. Oh, Lucas, just one, hon. All right. I know you want them all. All right. I need these 4 put in the envelope. And who gets Rose the black dot this last time?
We didn't
So who gets it? Okay, Chris gets this one.
And I'll be the manipulator. Lucas gets to be the manipulator. I get to be the manipulator.
There you go. And just wrote. And do we get all 4 in there?
Yeah, mine.
All right, guys. Let's see what you got.
Okay.
I get one.
Now we go up to this.
First problem was star plus star equals triangle. And since the stars were both the same variable, we knew that the triangle would have to be even number because if it was like 7, then the stars can't be the same variable.
Okay, cool.
So we knew the triangle had to be 2, 4, 6, or 2, 4, 6, 8, or 10.
Kevin, I'll be there in a
And
minute.
then, so after we went to the next problem, the triangle, we figured out that the triangle was 2 because it couldn't be 1, and since the answer was 3, it couldn't be 1, or because it wasn't even, and it had to be less than 3. So our only other choice was 2, and so that means, so we figured out up here that if that equals 2, then the answer would be 2, and then star would be 1, and so it'd be like 1 plus 1 equals 2, and then we figured out down here since star equals 2, and then the answer was 6. We knew that this square had to be 4 for
Awesome.
the answer, so we got
Great strategies. Awesome. So who had the black dot? Okay, so Dante gets it this time. Dante, no P. All right. Share those around, and you may move on. Who's got an explanation for me?
I do.
Okay, Susie.
We know that this has to be even because these 2 is a star is half of this, and we figured out the star is 1 because we then started working on the other ones, and we learned that with this one, if it equals 3, that would have to be 1. They would have to get 3. You have to add 2 and 1. So this one is 1 because this could be 2. Cool. And this one, we know that this one is 1.
Awesome. Awesome.
Yeah.
Right.
Yeah, and we double check
So if you guys can put those back in there, and I will grab your next one.
Where's the?
Oh, I have to raise my hand. Got the last time?
Ready?
So who gets it this time?
Amika?
Okay, Amika.
Oh yeah, can you sign this? So that means I'm the
And I'll take that.
manipulator.
And let me sign this.
Oh, so I just hand these out?
There you go, sweetie.
So I just hand these out to everybody?
Yeah. Put the black dot.
They're, oh yeah.
You get to
Okay, let's look at it first. Let's
My
look
journal.
at it for a bit.
Okay, here, I can hold on to your
I found that in my journal. It's the wrong card.
We tried to do 6 and 3 to equal 9 first, but to equal 6, these had to be 6
Okay.
So I also figured out that 5
black dot this time?
I guess it's my turn.
All right, and there are the rest of those. And I will take that. Awesome, thank you.
Counterbalance.
Randomly roll them out.
Wait,
Somebody have an explanation for me?
the blood. His blood. Stop.
Okay, and what was your strategy? How did you get
We used a black dot.
Okay.
And then we did the guess and check thing.
Okay, all right. So next time, see if you can find a strategy other than guess and tell. All right? Who is it? Who's ready for the black dot? Okay, there's that. There are those. Do we have all four there? Awesome. You guys are moving on.
I get that one on the hardest one. Joy, we have so much work.
Mine goes first because I'm okay. Tell us. Square plus star.
And make sure while she's talking, you get your strategies written down.
No one has a strategy.
Lauren, will you explain this?
Okay,
Please? Nice. I don't know if that was there, but that was a nice one. Yes. Go ahead.
our strat. Well, I kind of just worked backwards and tried to figure out what could be that equals.
Well, we started off with 1 and 8, and then we went to 2 to 7.
Yeah, because we thought that 1 and 8 could work there, and it worked for these two, but it didn't work for the top one.
Okay.
So we had to figure out what we had to readjust to change it in order to get the correct answer. So we changed that one to 2 and took that one down because that would still work out to be 9, and we just worked our way back up to the top.
Okay.
Work backwards like the sailor problem.
Okay.
And the
All right.
prism problem.
All right, and that's awesome. So this time, see if you can figure out another strategy besides work backwards. Okay, let's see if we can add another one to our toolbox. I need the 4 put in here. Who's my black dot person this
Cindy
time?
now.
All right, there's that, so don't turn it over yet.
Black dot yet?
No. Good for you. Awesome.
You should do it.
And Miss Lauren, thank you for volunteering, darling.
Oh, I want this one. Here you go, Donovan.
Okay, make sure you have your strategies down.
3 numbers? What else did you have for strategies?
We had to look at our black dot card. So our black dot card said that square plus 1 equals 6. So that means that square equals 5. And so then we worked backwards. And so mine is star minus square equals 2. So if this is 5, then that means this has to be 7 to equal 2. And then we figured out that this is 7, so then we went on and we did everything else.
Awesome. Okay, I need these in here. Who's black dot this time? I need all 4 in here. Is it you, Peter? Are you up for the black dot?
Yeah.
Okay, cool.
I'm like her.
I want to be black dot. I explained it last time and I didn't get a magic buff.
All right.
You're Raven.
All right. There is Peter's, and there are the rest.
Here, Peter.
I'll handle
Merry Christmas, Merry Christmas. Merry Christmas. Merry Christmas.
Guys, we're going to be working for about 6 or 7 more minutes. You do not have to have all levels done, but I want you to keep working toward it. I have a lot of you all at the same point, so. Dante's up, huh? All right, Dante, let me hear the explanation. Okay. Okay, awesome.
And with the star is triangle wants to. Triangle makes
Okay, awesome. So who gets the black dot this time? Okay. All right, there's a black dot. There's the rest of yours. All right, who's explaining this one? You, Thomas?
because they figured plus 1 would be 7, because then 7, which is stars, plus 1 plus 3 equals 11.
Awesome. Can you put your values down here? And you guys use all collected. You can select up this down. Oh, good looking. I saw that. Thank you.
Yeah, I think Hannah has to be in charge really.
Kyle, let me grab you. Let me hear. And tell me how you guys got the solution here.
Oh, because like we're trying to like figure out a bunch of these, so we like with the...
Plus 4.
Can you show me how I can put that into the problems?
Is this how it's supposed to look?
Wait, the triangle.
Okay.
That are on either side.
Next one.
Eyes up front on 3, 2, 1. Awesome. One of the fun things about an activity like this, there's just tons of great energy. One of the bad things is at some point in time, we've got to stop and kind of process through what we've done. So I'm going to give your group about 2 minutes, and in that time, I need you to take the level that you're currently on and put the cards back in the envelope, put the manipulatives in their respective envelope, and one person bring me those envelopes. We can talk about that because we'll come back to this. Okay, good. Oh, thank you, hon. Oh, you did. Oh, well, it says number shapes. Here, do it that way. I'll figure out. We'll get it. About 1 minute, and I should have shapes and manipulatives.
How do you know?
Oh, I keep
don't get it.
thinking things. I just love it.
I know it is contagious.
There's not really a right or wrong way. Forgiveness. Okay. Eyes up front, please. I've got most of your eyes. I know for many of you in this group format, sitting there and talking up this direction is awkward in where you are sitting. Just kind of rotate in your seat. I don't think you'll necessarily need to look at your notes, but I think you can talk out as we go through things. Thanks, Susie. All right. So I had a lot of you. We were very successful today. Many solutions were found. And we went through this process of using variables and talking about algebra. What was one strategy that your group used effectively? What do you think worked really well for your group? Maddie?
We looked at the numbers that were provided and pretty much just worked from there.
Okay.
And if
what would you call that strategy?
Resourcefulness.
Okay, we'll call it resourcefulness. All right, so we look at what we have, and then we go from there and we make educated guesses. All right, Lauren, what worked well for your group?
We kind of started at the end and then just saw the numbers and tried to piece it together.
Okay, so what would you call that?
Working backwards.
All right, we've got working backwards. Do we have other strategies? Luke?
Guess and check.
We did guess and check. And I think a lot of times as we're just getting into algebraic thinking, guess and check we use a lot. The more we are skilled in algebraic thinking, the easier it is for us to use strategies we've learned. But we're really kind of at the infant stage here. You guys have great concepts as far as algebra. But guess and check was a very successful strategy. All right, how about you, Max?
We did counterbalance.
Okay, tell me what that means.
Well, we worked off of one problem, looked at another one, and then tried a number, but that didn't work. So we'd go back to this other problem that had this one number, but then that number wouldn't work in this other problem. So this number, we tried in that other problem, but that problem wouldn't accept it until we finally found a number that worked in another problem that worked in all the problems.
We all got that? All right, okay, so Gavin's group does this. All right, back and forth. All right, but that counterbalance, I get, do we understand what he was saying?
No.
So we look, who can put that into their own words? What, I know Gavin has the gift of gab, but put that into something we all understand. Ollie?
So pretty much, it's kind of like common sense. If this here equals something, then it has to work in this problem too.
Okay, and I heard lots of what Alden is referring to as common sense. Some things you just knew, okay, it had to be kind of here because of certain characteristics. Who has an example of that? Knowing that something had to be a certain value because of an equation. Somebody have one of those, Kevin?
Like if you knew one thing was 3 plus something equals 4, then obviously it's...
All right, once you found one value, you were home free pretty much. Okay, so if you can identify one value, that allowed you to fix the others. All right, what else? Maddie?
Well, this doesn't go with common sense, but I guess this is like simple thinking. On set 3, I had a problem that was triangle plus 1 plus triangle equals 3, so I basically was just being a simple person and just made those all one.
Yeah, because there was no alternative, was there?
It worked.
No.
Yeah, and it worked.
Absolutely, absolutely. So some of that is very common sense. Yeah.
Logical prediction. So basically, you just take one number, like a triangle or something, and then just choose a random number for it and see if it plugs into everything else. And if not, you try another thing.
Okay, so logical prediction. All right, what kinds of comments were made in your group that you felt really helped the group work well, excuse me. What worked well with the kinds of comments in your group? Jasha?
Like when the manipulator would look at something and someone would say something worked, and they'd like look at the idea throughout the entire thing, say no, this worked, or no, I know this works, but not with this.
Okay, so they really illustrated the substitution. That really helped everybody understand it. What else worked well in your group? Patrick?
So like when we thought of an answer, but then like some person would like say that it wouldn't fit in their group, which.
Awesome. So you work cooperatively. I say, oh, I think this is one. No, it's not going to work in my problem because of this. Okay, then we can try something else. Awesome. What else, Sid?
Well, we like, if someone explained why, like why he thought it was this or why it was that, we could build from that and then like get different variables.
All right, awesome. So we have people explaining the why, their reasoning. Okay, sometimes that's very hard to do. Very hard to tell us what we're thinking. We know we're thinking something, but putting it into words sometimes is not an easy thing. Okay, Gavin?
When we said, let's look at the black dot.
Let's look at the back dot. And it was nice to know you had that little final hint. I did hear one group say, we looked at the black dot and that didn't help either. So sometimes,
Well, it did. It helped me.
sometimes it does and sometimes it doesn't. But it gives you another piece. Does somebody remember what we called it, where we had equations where every value was the same in that group? Does anybody remember what that was called? Because that's what we kind of, yeah.
Fact families.
They are fact families, awesome. Is there another term we use today that might have been new for some of you?
Factor trees?
Factor trees we can use. Begins with an S. Anybody remember?
No, never mind.
Luke?
Substitution.
We use substitution, but it's where this equation and this equation and this equation and this equation all solved the same way. The triangle was always the same. The star was always the same. The square was always the same. You think you got it, Dante? It is some. What's something that fits together in a group and all works together that begins with S?
Sid.
Sid works together. What? It's a different word.
Similarity.
System.
System of
Similarity.
what? What are we dealing with today? Equations. Okay.
Oh, wow.
System of equations. Now, as I indicated to you, systems of equations are something we do in algebra. Okay? But it made sense for us to understand that concept right here because by knowing that they were related, it helped us in solution. All right? Okay, now what I'm going to do at this time, all of you have your note takers out, and I'm going to collect them in just a couple of minutes. But the very first page of your homework is reflective. And what this means is it should take you back to what you've done in your group and kind of thinking about what we understand now about equations. I'd like for you to take a minute, and at this time, I don't want you to respond with your group, but rather I want you to kind of reflect and jot down what you've noticed in response to the questions that relate to equations, all right? So once you have yours, write your name on that, and we're just going to take about a minute to reflect, and then we're going to wrap things up for today, and we'll go from there.